Hello and welcome back. In this video, we're covering section 7.7. We're completing our series of videos on these additional trigonometric identities and formulas. So these will be called product to sum and sum to product formulas. So let's just take a look at them and see how we can apply them and what they describe. So let's start with the product to sum formulas. So when they say product to sum, notice what this formula is describing. We have the sine of some angle times the sine of some other angle. So a product of two sine functions with different angles, we can express it in terms of some angle subtraction. So when they say sum, we can view a subtraction as a sum as well. But they're no longer multiplied together. So we're splitting it into some sum or difference. And we can do that also with the cosine of some product. So cosine of alpha times cosine of beta can equal 1/2 cosine alpha minus beta plus cosine alpha plus beta. Or we have a similar one for sine of some angle times cosine of another angle. It can be split into the sum of two sine functions with the sum of the two angles in one and the difference of the two angles in another. So we're making our list of identities ever larger. So let's just reference these formulas and work through how we can apply them by plugging in our values and evaluating. So let's start with example 1. We're given, for part A, the sine of 6 theta times the sine of 4 theta. And it says to express each of the following products as a sum containing only sines or only cosines. And we want to express this product as a sum. So let's use this first formula here. Sine of alpha times sine of beta. This can be like our alpha, 6 theta, and the 4 theta is our beta. So this can be written as 1/2 times the cosine of alpha minus beta. So this would be 6 theta minus 4 theta minus the cosine of alpha plus beta. So 6 theta plus 4 theta. So let's just simplify things. This will be 1/2 times the cosine of 2 theta minus the cosine of 10 theta. And that's all they're wanting here. They just want us to apply this formula. So we expressed this product of two trig functions as a sum. Technically, it's a difference here. And this is another example. I kind of mentioned this in the last video too. This is another example of a skill that's going to be useful later on in the middle of a larger problem in calculus. Because you might argue, well, this seems a bit more simple on the left side. Why would we want to make it more complicated? The reason for that will become more apparent a bit later, but it might be beneficial at some point to have just a sum or difference of some trig functions instead of some that are multiplied together due to rules of some higher order operations like integration. So let's continue with our examples here. We have the cosine of 3 theta times the cosine of theta. So let's reference, I'll leave it at the top here. We're looking at this one. Product of two cosines. This will be equal to 1/2 times the cosine of alpha minus beta, so 3 theta minus 1 theta, plus the cosine of alpha plus beta. So cosine of 3 theta plus 1 theta. All right, let's simplify. So 1/2 times cosine of 2 theta plus the cosine of 4 theta. That's all they want for this one. So we express the product of two cosines as the sum of two cosines. And then part C, they give us, I'll just write it here first, the sine of 3 theta times the cosine of 5 theta. So that one is our third formula here. So 1/2 times the sine of the sum of the angles plus the sine of the difference of the angles. So let's use that. So it will be 1/2 times the sine of 3 theta plus 5 theta minus the sine, or no, I'm sorry, plus, right? Let's take a look. Yeah, plus the sine of 3 theta minus 5 theta. So let's simplify this. 1/2 times the sine of 8 theta plus the sine of, this would become negative 2 theta. So there's nothing necessarily wrong with that, but recall that we can use the odd property of the sine function, that if we have the sine of a negative angle, that's equal to negative sine of the positive angle. So we can effectively take this negative and bring it out in front. And I think that's what the text likes to do, to avoid those negative angles inside. So 1/2 times the sine of 8 theta, this can become minus the sine of positive 2 theta, just using that odd function property. Yeah, we can leave it here. So that's taking a product of two trig functions, either two sines or two cosines, or a sine and a cosine, and expressing it as a sum or difference of individual sine or cosine functions. So we can add these to our list. And we can go the other way too. We can have a sum and turn it into a product. So that's what our second section is on. So we want to express sums as products. Meaning if we have the sine of some angle plus the sine of some other angle, we can use this formula to express it as a product of two trig functions. So we get rid of this sum or difference in between and produce a single term. So we have formulas for the sum of two sine functions, the difference of two sine functions, and the sum of two cosines and the difference of two cosines. So let's use these and evaluate a few examples here. So part A gives us the sine of 5 theta minus the sine of 3 theta. And it wants us to express each sum or difference as a product of sines and or cosines. So we have the difference of two sines. Let's use this second formula. So just following what's written here, this should be 2 times the sine of, and inside the sine, we have a fraction where we have the difference of the angles. So 5 theta minus 3 theta. And this is over 2. The Then this is multiplied by the cosine, and inside the cosine is the sum of these two angles, so 5 theta plus 3 theta, also over 2. So let's just simplify this down. This will be 2 sine of 2 theta over 2, so that will just reduce to theta, times the cosine of 8 theta over 2, so that should reduce to 4 theta. And then for part B, they give us the cosine of 3 theta plus the cosine of 2 theta. So sum of two cosines, we're going to use this formula, so let me just write it in and then I'll scroll down. So it'll be 2 times the cosine of the sum of our two angles, 3 theta plus 2 theta over 2, times the cosine of the difference of the two angles, 3 theta minus 2 theta over 2. So this will simplify to 2 cosine of 5 theta over 2 times the cosine of 1 theta over 2. So we'll just say theta over 2. So this section is just having us practice with these product to sum and sum to product formulas. And I won't be asking you to memorize these. These are getting pretty complicated, and we have a pretty long list of identities already. But definitely know that these exist and that they can be referenced whenever we need to do something like this, like express a sum as a product, or from our first example, express a product as a sum. So this was a quick section just showing this last little set of formulas. Product to sum, sum to product, and the homework exercises will just be practicing working with these and plugging in our values, and ultimately maybe evaluating a few of them as well. Okay, that's it for this video, and I'll see you next time.